So in this section, we are going to study the flyby using the idea of the scattering process. So now spacecraft approaches the Jupiter from the back. So spacecraft is coming to approaching the Jupiter. Then is the spacecraft accelerated or decelerated? So we'd like to consider the scattering process of a spacecraft by Jupiter. We have already studied the scattering process of the planet. So Jupiter, the spacecraft is approaching to the Jupiter with the initial velocity. This is initial. And approaching the Jupiter. Then because of the gravitational attractive force, the orbit of the spacecraft is changing. Then this is the final. After the scattering by Jupiter. So the velocity vector is changing from the here, this direction to this direction. So relative velocity, right? We observe the motion of the spacecraft from the Jupiter. Initial velocity is this direction, then changing to the final velocity this direction. By considering the scattering process by Jupiter. Then the magnitude of the relative velocity doesn't change because of the conservation of the energy. In the case of the scattering process, hyperbolic orbit. But the direction has been changed. We look at the motion of the spacecraft from the Jupiter. But the Jupiter is also moving, rotating around the sun. Then when you consider the motion of the spacecraft reference frames in which the sun does not move. In the last frames, in these frames, Jupiter is moving with respect to the sun. So in the next frames, sun does not move. Instead, Jupiter is moving. Relative velocity is expressed v spacecraft minus Jupiter's velocities. So to find the velocity of the spacecraft in a frame that sun does not move, then we have to add the two velocities. U is the relative velocity with respect to the Jupiter and the velocity of the Jupiter. So velocity of the Jupiter is expressed by this blue vectors. This is the velocity of the vectors. Velocity of the Jupiter. The initial velocity before interacting with the Jupiter, velocity of the spacecraft is this direction. The velocities of the spacecraft with respect to the sun is expressed as sum of the two vectors, relative velocity and the velocity of the Jupiter. So this is the initial velocity of the spacecraft with respect to the sun. Then after the interaction with Jupiter, relative velocity is changing to this one. This relative velocity. So velocities of spacecraft with respect to the sun is changing. Then velocity vector is changing. Actually, magnitude of the velocity vector is increasing. So this means spacecraft is accelerated by the gravity of Jupiter, and it can move outward. It is accelerated. We use these ideas to accelerate the space probe and send the space probe to the outer solar system. This is the idea we use to send the Voyagers to the outer solar systems. Voyager launched on the Earth in the 1977. Approach to the Jupiter 1979. Voyager is accelerated and moving toward the outer solar systems. By using the gravity, Jupiter and Voyagers are able to move outward. Okay, this is the end of this session.